sharing my screen. Next thing that I wanted to do was, oops, I thought I had this open already, and I guess I don't. I apologize. I wanted to go through and just open my labs math and ask if anybody has any questions on any of the problems that are in the homework. Does anybody want to go over any of the homework questions? I know last class we spent a bit of time just looking at examples of word problems, and that's something that you really just need to practice. But does anybody want to look at any problems from any of the homework assignments thus far? Also, my 8 o'clock class told me that the audio was picking up. If you can't hear me, if that happens, please let me know and I'll start using the headset.
It was better when everybody muted, but it was in the beginning just a little bit breaking up.
Okay, let me go through and use that headset. Does anybody have any homework problems that they want to look at? And while I'm talking about the homework, I noticed in all of my classes, there are some people that have done some of the assignments, but skipped over some, and the ones that they skip over said past due. Does everybody know that even though an assignment says past due, you can still work on it and you can still get credit for it? There's a slight late penalty, but getting credit for it, even when it's late, is a heck of a lot better than getting a 0. I don't submit those zeros for missing assignments till the end of the semester. If you have any late homeworks, it's better to do them than not. And also, everybody's aware that you get 3 tries on a homework problem. After 3 tries, if you still get it wrong, there's a button you can push and you can have infinite do-overs on the homework. You can keep doing them over until you get them right. And does everybody know where they can, in the homework, send me an email if they have a question on the problem that they're working on? Because I don't want anybody to stress over a problem in the homework. You know, if you've got a question, please ask me right away and I can help you with it. Anybody want to look at anything homework-wise? You guys are scaring me because usually when I teach this class on campus, we probably spend about a quarter of the class time going over homework problems or working out homework problems together. And you guys never ask questions. Can I go on the assumption that y'all know what you're doing? Or should I get scared and think that means?
I think that it's not. I find
We're fine.
a hard class to do in Zoom. Maybe the younger people are good, but
Well, just ask questions. When I give the notes in Zoom, is that kind of like what you would expect from a regular class?
yes. Yeah.
I'm trying to make this as much like a regular class for you people as possible. I really wish that background noise wasn't a problem, but please, if this were a regular on-campus class, I would hope that all of you would be comfortable if something's not clear when I do it, to ask me. Usually even in class, I don't have people raise hands or anything. I would much prefer the conversation because we're all adults. I would appreciate it if you just said something. Go over that again. What does that mean? You know, you're going too fast. As much as you need interaction from me, I need interaction from you to make this Zoom meeting work. So please, if you know, feel comfortable speaking up, all right? That having been said, the only thing that's on this first test that we have not yet talked about are inequalities. So today we're going to start looking at those. The inequalities are what's over here, homework 10. The homework 7, 8, 9 are problem solving. Do you folks think that you will get through those by the end of the day today? Or does anybody think you'll need extra time on those?
Might need a little bit extra time.
Okay, so how about, I know it's not a class day, but let's add 2 more days. Would everybody all right if I change that to the 19th?
Yes.
Okay.
Yes, that's fine.
And I also want to give you a heads up in terms of responding to email. Usually I try to do that quickly, but my husband and I are going out of town this weekend to visit our daughter and see our new grandson. And so I might not be as quick as responding to emails, but I will respond to emails. Usually outside of class time, I'm also okay like doing Zoom meetings, but because we're going to be at her house, I'm not sure if I'll be able to do that. But I apologize in advance. My response time might be a little bit slower than normal this weekend.
Super exciting. Congratulations.
Yeah, well, he was born early in June, and we saw him when he was brand new over the summer. But they've been portaling us a lot with him and saying, "Oh, you guys should come. Oh, you guys should come." It's like they really want us to come visit. We really want to see him again. So he's a kid. I'll have to show you guys pictures of class. But that having been said, when I talk about inequalities, we've been working with equations. Now we're going to start working with inequalities. Has anybody ever heard of inequalities? We're going to look at symbols of inequality first. And the first symbol we're going to look at is this one. Anybody know what that symbol means?
Greater than,
Close. So
less than.
it's the other one, it's less than. Now, I know some people, the way I frequently get left and right confused, some people, interchange them. When I look at that less than symbol, you hold your head crooked a little bit. Does it kind of sort of look like a crooked uppercase L? So that helps me remember that it's less than. And so if I were to write x is less than 5, it would mean that x is any value less than 5. Usually with inequalities, we draw them on a number line. And is everybody familiar with what I mean when I say a number line? A number line is an infinite line. We're worried about numbers around 5, so I'm going to center mine at 5. Your integers are evenly spaced. And I'm sorry, that shouldn't be negative. I apologize. Numbers get larger as you go to the left and smaller as you go to the right. So a value is less than another. If it's to the right on the, I'm sorry, I'm getting my hands mixed up. If it's to the left on the number line. And so over here, when I look at x is less than 5, it means that x is any value to the left of 5, but it does not include 5. And if we're not including, we use an open dot to show we're not including. So I'm going to redraw my number line. I'm worried about values near 5. If I'm looking at x is less than 5, I don't include 5. So I'm going to put a circle around 5, but I'm going to leave that circle open. I want values smaller than 5, so those would be to the left of 5. And so if I wanted to show x is less than 5 on the number line, it would look like this. I don't think you're going to see it often in this class, but sometimes you see something that's called set builder notation. And so what I've got on the number line are values less than 5. Sometimes you see it written something like this. And it's just a way of saying this is read as. This first part read as the set of all x. The line is read as such that, and then what value follows is a description of what x can be. So here our description would be that x is less than 5. So let's look at another one. Let's sketch on a number line. Let's say the set of all a such that a is less than -2. Can I scroll this up? Am I going at an okay pace for everybody?
1 second.
Okay. Ready?
No.
Yeah, thank you.
This sentence is just notation. It's saying, okay, all right, I'm looking for a group of numbers. That's why it's a set. I'm going to use a variable to represent them. What's in front of the line tells me the letter I'm using. So I'm going to use A. And then what's behind the line tells me what's special about A. A is less than -2. So on my number line, I'm going to find -2. I don't include -2 because I want smaller than -2. And the smaller values are to the left. Is everybody comfortable looking at this and drawing it on the number line? If
Yep.
so, next place we're going, I bet you can guess, is this
Greater than.
greater than. And the greater values are to the right. And so if I have that, let's say Z is greater than 42, and I want to sketch on a number line, I'm going to draw my number line. And I have to tell you, I'm lazy. I don't feel the need to put all of the numbers on there. The one number that I do need, though, is 42. My variable is bigger than 42, but I'm not including that 42, so I'm going to leave that open circle. And Z is on the larger side, so we'll color to the right. That one all right. One thing we have to be careful of, if I am saying that Z is greater than 42, doesn't that mean the same as 42 is less than Z? When it's written like this, we're saying that 42 is smaller than Z, and so that's telling me that 42 is to the left of my values, and it would give me the same number line graph. It's very childish, but I've been told a lot of people look at the greater than less than sign as a mouth and put teeth in here. And you always want to eat more, so it's open to the larger side. Whichever way the greater than or less than sign is, the larger value is the value that the symbol is eating. Has anybody seen that one before?
Yep.
Okay. Then the next two are very close to the greater than less than, but they differ by just a single value. If I have this, my less than symbol, but there's a line underneath. When I draw that line underneath, that bottom part of that symbol looks very much like an equal sign to me. And so I read this as less than or equal to. And so let's say, for example, I have y is less than or equal to 8. This time, because it can equal 8, we're going to include the 8. And so When we didn't include the 8, if I draw my number line, when I did not include the 8, I had an open dot, and here I have an arrow to the left. When I include it, what I do is I color in the dot. So we use a closed dot if we can include the value. And so if there's that equal sign at the bottom of the symbol, I'm going to color in my dot. You folks, because you'll be doing most of your work through My Math Lab, usually with questions involving these inequalities, they're multiple choice. And so if there's that equal sign there, you're going to use the one where the dot is closed in. If it's not there, you're going to use the one with the open dot. Last symbol of inequality then is this. And this one is greater than or equal to. And so if I have, for example, x is greater than or equal to 1/4. When I draw my number line, 1/4 is in between 0 and 1. I believe with ones like this on My Math Lab, they show those larger values. And then I'm going to put my quarters in there, dividing that into 4 equal parts. Because of the equal sign, I know I'm including my 1/4, so I'll color it in. And X is on the larger side, so I am shading to the right. So that the equal sign tells me that I'm using my closed dot. So far, so good. Any questions?
No.
Okay, then we spent a bit of time the last couple of classes solving equations. Today we're going to start by looking at solving inequalities. And when we solve equations, we usually got single answers. When we solve inequalities, we usually get U-S-U-A-L-L-Y. Do you ever get halfway through a word and forget how to spell it? Usually, we get an infinite number of solutions. And when we get that infinite number of solutions, this is when we use set builder notation to give our solution set. And so with these in My Math Lab, they'll have the set of all x such that, and you need to fill in the blank. Here you're going to write your inequality. Including the variable. And usually I ask you to show the solution set on the number line. So that's how we're going to put our answers. We need to know how to find our answers. And can I scroll up?
Yes.
So
Yes.
when we solve inequalities, it's very similar to solving an equation. There's really only one place where it's going to differ. But because it's like solving the equation, the first thing that we want to do is we want to simplify each side. And then we're going to use the addition or subtraction property of inequality to get the variables together and the constants together. And that's usually what we did when we solved an equation. We simplified each side as much as possible, and then we added or subtracted to get all of the variables on one side and the constants on the other. This time, though, instead of using the addition property of equality, we're using the addition property of inequality, which says you can add or subtract the same value to both sides of an inequality, and the direction stays the same. That's wordy. I like to write it instead with symbols. I'm going to say that if A is less than B, then A plus C is less than B plus C. I'm adding the same thing to both sides and it stays the same. Or A minus C is less than B minus C. Whatever my inequality is, if I add or subtract the same thing from both sides, the direction of the inequality stays the same. So let's take a couple seconds and then look at an example. Let's solve and graph the solution set. And I'm going to have x minus 6 is less than or equal to 10. Should I wait a minute before we start solving this, or are you folks all caught up?
No, 1 second.
Okay, just let me know. You ready?
Yeah.
Just like an equation, our goal is to try to get the variable alone. The difference is we don't have an equal sign here, we have an inequality here. As I look at the left-hand side, those are not like terms, so I can't combine them. And there's just a single value on the right, so I can't simplify that. In order to get the x alone, if this were an equation, would everybody recognize that we need to add 6? And if I add 6 to one side, I have to add 6 to the other. Those 6's are equal, so I'm going to put an equal sign in the middle, but with the addition property of inequality, when I add the same thing down, I'm going to keep my inequality. So we'll get x is less than or equal to 16. And you see how similar that is to solving an equation, except it's an inequality. If I were to first graph it, I'm looking for values around 16. With this one, should I have an open dot or a closed dot?
Closed.
Beautiful. Because we've got that equal sign at the bottom, we're closed. And then is x on the small side of the symbol or the large side of the symbol? On the smaller side, so we'll color to the left. In our solution set, again, in my math lab, they're going to have it started for you, the set of all x such that. What you have to type in here is not just less than or equal to 16, but that x is less than or equal to 16. So here, you fill in that blank, you're going to type in the inequality. Is that one all right? Any questions? If not, let's look at another example. This time, let's look at -2 is less than x minus 4. There's only one value on the left, nothing to simplify. On the right, does everybody recognize that the x and the -4 are not like terms, so I can't combine them? In order to isolate the x, in order to get the x alone, we'd have to move the -4. And the opposite of -4 is +4. And even if it's an inequality, what we do to one side, we have to do to the other. And if we're adding and subtracting, as long as we do the same thing to both sides, the direction stays the same. -2 + 4 is 2. and then we're left with x. So here we're saying 2 is less than x. We can write that as the set of all x such that 2 is less than x. Or, is everybody all right? 2 is on the smaller side. X is on the more open side. We could write that as x is greater than 2. As long as in both of these inequalities, x is on the large opening and the number here is on the small pointy side, they're equivalent. On a number line, when I put my dot on 2, this time, should it be open or closed?
Open.
Open. And this time, the variable is on the larger side, and so we'll shade to the right. And you see how if I'm adding or subtracting, whether I'm adding or subtracting a positive number or a negative number, the direction of my inequality stays the same. The only time you have to be really careful with solving these inequalities is when you multiply or divide. Can I turn the page and not lose anybody?
Wait, isn't 2 less than x? So shouldn't it go the other way?
2 is less than x. 2 is on the small side, so 2 is to the left.
No, I'm talking about the line.
Here or here?
Where you put it on the line, isn't it supposed to go the other way if it's less?
No, because if 2 is less than x, that's the same as saying x is bigger than 2, right?
All right, yeah. So,
Okay. If that's all right, then the next thing I'd like to do a couple of examples for you before we look at the rule for the multiplication property. Actually, let's look at the multiplication and division property. Of inequality. And I'd like to start by looking at an example. If I say that -7 is less than 5, are we all in agreement that negative numbers are smaller than positive numbers?
yeah.
What I'd like to do is I'd like to multiply both sides by, let's say, +2. So I'm going to take -7 and multiply it by 2. I'm going to take 5 and multiply it by 2. I want to do the same thing to both sides of my inequality. And when I do that, -7 times +2 is -14. 5 times +2 is 10. And wouldn't the direction stay the same? Isn't the negative still smaller than the positive? And so the first part of this property says, if you multiply both sides, or divide, pardon me, both sides of an inequality, by the same positive value, the direction remains the same. Please notice, though, that we multiplied by a positive 2, and we multiply by a positive 2, the direction stays the same. What's going to happen if instead I have that -7 is less than 5, and this time, what happens if I multiply both sides by a -2? If I take that -7 and multiply it by a -2, negative times negative is positive, so that gives me positive 14. On the other side, if I take that 5 and multiply it by a -2, positive times negative gives me -10. Now, which is bigger, the positive 14 or the -10?
Positive 14.
Positive 14. And so do you notice when we multiply by a negative, it can have the effect of changing signs, which reverses the inequality. So if we multiply or divide both sides by the same negative, the inequality reverses. It changes direction. So the only time you really have to be careful is you have to remember that if you multiply or divide by a negative, it changes direction. Otherwise, solving an inequality is very, very much like solving an equation. The only time you have to be careful again is if you're multiplying or dividing both sides by a number. You have to realize that if that number is negative, I have to switch my inequality. So let's solve, write the solution set, and graph it. So let's solve, write, and graph the solution set. Is everybody ready?
Yep.
So let's look at the example. Let's look at 1 minus 5x is greater than -9. Can I simplify the left? No, they're not like terms. Can I simplify the right? No, there's just a single value. Whenever I solve, my goal is always to get that variable all by itself. In order to solve for x, what should I move first? The 1?
1 on both sides.
And so we'll subtract 1 from both sides. And because we're adding and subtracting, nothing changes. We've got -5 is greater than -10. Now, this is -5 times x, so we'd have to divide. And because I'm dividing by a negative, all sorts of buzzers and whistles are going up in my head. If I divide or multiply by a negative, I have to switch directions. So that gives me x is less than 2. If I multiply or divide by a negative, I have to change my directions. Now my variable is all alone. Set builder notation, set of all x, such that, remember when you write that inequality in the homework and the tests and the quizzes, you've got to retype the whole inequality there in that set. And on a number line, I'm going to be lazy and make my number line short. I'm worried about year 2. Open dot or close?
Open.
Open. There's no equal sign. And is x on the smaller side? Do I shade to the left? Or is x on the larger side? Do I shade to the right? Are you saying x is smaller than 2 or bigger than 2?
Less than, so smaller.
Smaller, so we're shading to the left. We'll try another. We ready to turn the page?
Yeah.
Oops, I gotta press the button. Next example. Let's say that -9 plus 5 is greater than or equal, I'm sorry, -9, I misspoke it, I apologize. It's -9x plus 5 is greater than or equal to 4, and then in parentheses, I'm going to have 5 minus x, close parentheses. When I solve these, I have to leave that inequality there so that I know the direction. I've seen some students lose that. No, that's going to stay greater than or equal to. The only time the symbol there will change is if I multiply or divide by a negative. On the left-hand side, is there any work to be done? Are there any like terms? No. On the right-hand side, can I simplify that? How would you simplify that? What do you need to do?
Multiply.
And how would you multiply? Would you multiply the 5?
4 by 5 and 4 by x.
Yep, beautiful. We're looking for that distributive property. So this side becomes 4 times 5, 20, minus 4 times x, 4x. The other side right now stays the same, and the inequality stays the same. Now, personal preference. I like to get all of the variables together first. So we have a choice. Would you rather move the -9x Or would you rather move the negative 4x?
4x?
4x? And since it's minus 4x, we'll add 4x. Now here, I'm going to put an equal sign in between them because they're equal. I want to make sure I'm doing the same thing to both sides. And again, I like to put that equal sign in the middle to make sure I am doing it to both sides by lining up. Negative 9x plus 4x is negative 5x plus 5 is greater than or equal to, that would be 20. 4x minus 4x is 0, so they're gone. Now that all the x's are together, we need to move that plus 5. The opposite of plus 5 is subtract 5. Those are equal because I'm doing the same thing to both sides. So I get negative 5x is greater than or equal to 15. Now, to get the x all alone, this is negative 5 times x. The opposite of multiplying is dividing, and we divide by the same quantity. So I'm going to divide both sides by negative 5. That gives me x. And then, because I'm dividing by a negative, I've got to change the direction. And 15 divided by negative 5 is negative 3. So I'm left with x is less than or equal to negative 3. On a number line, open or close? We'll leave that dot open, or should I color it in, and why?
Color it in because it's less than or equal to. It's not
Beautiful.
less than or greater than.
Beautiful, because that equal sign's at the bottom, we're coloring it in. And now when I shade, is the x on the lesser side or the greater side? Less than, so we'll color to the left. That one all right. If so, that's really all there is to solving inequalities. It's very much like solving an equation. The only time you have to be careful is if you multiply or divide by a negative. If you multiply or divide by a negative, you have to change the direction. And you need to remember, if there's an equal sign at the bottom, it's a closed dot. If there is no equal sign at the bottom, it's an open dot. That homework 10 is practice solving these inequalities. And up to this point, ratios, percents, solving equations, and solving inequalities is what their test will be on after class Tuesday. We'll go over a practice test on Tuesday. Does anybody have a question on these inequalities? If not, I want to just do a little bit, a very little bit of introduction to that next section. Can I turn the page? In that section, I like to refer to it as a Cartesian plane. Has anybody ever heard of the Cartesian plane?
No.
The Cartesian plane is named after Rene Descartes. Descartes is probably as famous in philosophy circles as he is in math. And so it's called the Cartesian plane because this fellow, Rene Descartes, made significant contributions to math. You might know it as the rectangular coordinate plane. Oops. And while you might not have heard its fancy pants name, I'm thinking that if I draw the coordinate plane, it's gonna look familiar. And I apologize. I can't draw a straight line if my life depended on it. Does that look at all familiar to anybody? It's a plane. Since it's a plane, it's an infinite flat surface. So I'm only drawing here a small part of it, but it's important that I put those arrowheads on because technically it goes on forever and ever in each direction. It contains two axes, which are number lines. That intersect at a right angle. At a common zero. So these two lines that I draw are number lines and where they cross a zero. So one will get larger as it goes to the right and smaller as it goes to the left. The other will get larger as it goes up and smaller as it goes down. Is it looking any more familiar? Can anybody remember the name for the horizontal line? The horizontal line is usually labeled with X so that the x-axis is horizontal. And having given you that one, can anybody remember what the name is for the vertical axis?
Why?
Y. So the y-axis is vertical. And just, I'm not a real big grammar person, but if you're wondering, axis is singular means one. Axes is plural when you talk about more than one. So the relationship between axis and axes is very much like the relationship between one mouse and two mice. Axes is the plural. The point that the axes serve is to help locate points. So points are located by ordered pairs that are called coordinates. So for example, let's say I have a point A and I say its location is 2, 1. When I look at the ordered pair, they're always in the same order. And man, when I was a kid, I was stupid. I used to get confused, which is first, which is second. And somebody just had to whack me up inside and say, they're in alphabetical order, silly. And so if you think alphabetical order, the first one's the X value and the second one's the Y value. So the point A is going to be have an X value of 2 and a Y value of 1, which means I'm going to go up to 2 on my X axis. I'm going to go to 1 on my Y axis. And if I draw a vertical line through 2 and the horizontal line through 1, and usually you're doing this on graph paper, and so you don't even have to draw those dotted lines in on your own. Does everybody see that the 2 and the 1 would multiply here, and I would call this point A. Instead, if I had a point B and it was at 4, -3, again, the first is the X value, so I guess I can make this a little bit longer. X value is 4, Y value is -3. And so if I were to follow along the grid, picture this being on graph paper, this would be my point B. Has everybody plotted points in the plane before? Is this familiar territory?
Where does the 4 and the -3? I see the 4 to the right on the X plane, and then,
-3 is on the Y line.
oh, right, okay.
4 is on the X line, -3 is on the Y line. The next one I'm going to do a little bit differently. This time for C, I'm going to plot the point, and I'm going to ask you both to give me the location of point C. And so if this here is point C, I need to come up with its ordered pair. So first let's compare C to the X-axis. What number does it sort of line up with on the X-axis? Remembering X is the horizontal. C would have an X value of, does everybody see -1? And now for the second, I want to compare C to the Y value, the Y-axis, pardon me. And on the Y-axis, C is across from -2. Has everybody plotted and read points before?
Yeah, I think so.
And honestly, I guess nobody uses an old-fashioned map anymore. But I remember the first time I learned about this, people didn't have a phone with GPS in their pocket. And so, if anybody ever used a map and had to look up a street on a key, and there was always like a letter and number, and you had to follow the grid to get there. What we're doing here is very similar to that. In addition to locating points, we're going to say that the axes divide the plane into regions. So I'm going to do a real rough sketch here. Even when I do my roughest of sketches, I like to put X on the horizontal and Y on the vertical so people know which is up and which is down. As I look at this, when I draw those lines in, if the paper that I'm writing on is my infinite surface, does everybody see that I get 4 regions? They're numbered 1, 2, 3, 4. They're numbered with Roman numerals, counterclockwise direction. So they're called, is somebody in the cafeteria or something? It's getting a little loud. It's called
Oh, apologies, yep.
and the quadrants are corners. They're usually labeled with Roman numerals. Not ramen noodles, Roman noodles. Oh my heavens. We start, the first quadrant is where everything's positive, and you go in a counterclockwise direction. Counterclockwise, not counterclockwise, sorry. There's actually, though, 5 regions. You have the 4 quadrants, and the 5th region is on the axes, on the number lines. And there's a special name given to the point where the axes intersect. Can anybody remember the name for the point where your x-axis and your y-axis intersect? Anybody remember the name of that?
Like the beginning or something.
I like that in the beginning. In the beginning, it's where everything starts, and so it's called the origin. And the origin is the point 0, 0. It's at 0 on the x-axis and 0 on the y-axis. And I do believe that homework 11 starts with the idea of just plotting points. And as much as I want to go further right now, because I'm on a roll and I like graphing, I'm just thinking that maybe I'd like to, in terms of new notes, stop here because I don't want to go too much further before on Tuesday we go over the practice test, because this stuff isn't going to show up until exam 2. Just wanted to start with a little bit of this new definition and stuff. Is everybody familiar with everything we've defined thus far today? What's going on here? So I'm going to stop sharing for a second, and I want to look at you folks. If we were in an on-campus class right now, what I would do is I would stop and I would give you folks this last half hour of class to just practice. I would have you work on your homework in my labs, and I would walk around the room and help. That's the only thing I haven't figured out how to do in this Zoom structure. So, and I can't see anybody's faces, so I can't read expressions. So could everybody unmute for a minute, and can I talk to you about a way in which I can give you practice where if you need help, I'll be there for you. Is everybody in front of a device right now where you can open your My Labs and do your look at your homework?
Yes.
Yes.
Yes?
Yeah.
Yep.
Okay. Then how about we take a little bit of time for you guys to open your My Labs and work on the problems. And because on my other computer, when I have My Labs open, I have the teacher view. If anybody has a question, you can raise your hand and like message me in the chat, and I'll open your assignment and look at that problem with you. Would that work? Or if anybody has a question, you can ask, and we'll just pull up that problem for everybody in the class. Which works better?
Are we going under My Lab Math all assignments?
Yep.
Can you repeat that?
I would like to give everybody time to practice on the homework. And so could everybody open their My Labs Math and look at the assignments? And if you have a question, please raise your hand or something and let me know. And I will open that question and go over it with everybody. So you're going to go into Blackboard, into My Labs Math, all assignments, and just open and work on whatever homework you've been doing. And I'll, it's just going to be like practice time for a while. I want to show you folks though. You see how all of these say past due? You can still click on them and work on them. It just means there's going to be a slight late penalty because you're doing them after the due date. But please, if something says past due, please still do it. And if there was a reason beyond your control that you did not get them done, send me an email and I will take away some of the late penalty for you. But is it all right if I stop the talking and have you guys work on whatever you're doing in the homework? And if you have a question, you can ask and we'll pull them up for everybody?
Yes, that's fine.
Okay. All right, then let's take the last, it's probably about 25 minutes now, and have you guys just work.
And homework 10 is the one that you just went over today.
Right, homework 10 is the one on the inequalities that we went over today. The graphing is not until homework 11, which is after the test. So homework 10 is what we did today. And the problem set 1, everybody must do. It's a practice test. Okay, more people are here than when I first took attendance, so let me double check that too.
Can I just ask you a quick question?
Surely.
Is there something you suggest, like I need to remind myself of the properties, like the basic things we've gone over, like, so I have something. Do you think those little trifold things that you can get at like Barnes and Nobles that have all the basics, like something like that would be?
It would probably be helpful. Let me look for a minute. When you are in My Labs Math, instead if you go to the course home, in course home, except it's going slow. There's there used to be a review sheet built in here. I'm looking for it. Let me look and see if I can find one for you. I know they used to have one digitally in My Labs.
Okay. Or I can look too if I'm.
Yeah. There used to be a section, Tools for Success. They're flashcards.
Okay.
I don't know what there's on them, but there's flashcards. Let's see. We were in chapter 5. Let's see what's in there. Oh Lord, where'd it go? I don't know how they work.
Okay, I'll take a look and look at all the different,
There's
Hey,
spreadsheets
Professor.
in there. Yeah.
Um, I just got kicked out of Zoom. I just got back in.
Uh-huh.
Uh, are we on, where are we on the math lab?
You are working on whatever assignment you need to work on. The one
Okay.
that we covered in class today, what we did with the inequalities is an assignment 10. But you're working on whatever, wherever you are right now, whatever you need to work on. Next class,
Okay.
we'll be working on that problem set. Please, over the weekend, try to do that on your own.
Okay,
Okay?
thank you.
Oh, here's a basic math review card. Then do you see over here, there's a basic math review card and also an algebra review card.
yeah, so,
So it's in learning tools, which is in the video library and resources. Oh, they have it in Spanish too.
mine says My Lab Math Multimedia Library.
It doesn't say video and library resources?
Well, I've got the My Lab Math, under My Lab's Math is My Lab Math, all assignments, then My Lab and,
No, go in Blackboard. What you're going to do too is you're going to go to My Lab Math Mastering Course Home. So once you're in the course home in Blackboard, there's a video and resource library on the left-hand side. First go to the course home, then go to that video and resource library. Do you see where I am, hon?
Yep.
And in there, in learning tools, there's a basic math review card and an algebra review card.
Okay.
And I think that's what you were looking to buy?
Yeah.
Yeah,
Perfect.
but you get them with the digital book.
Okay, perfect.
Okay?
Thank you.
Okay.
Has NTRIP talked about possibly opening back up a little bit?
Not for classes that are not on, already on campus, that I have
Okay.
not heard.
I gotcha.
I am not sure. Let me double check and see if it's something that the division would let me do. If they do, would anybody be interested if I could find an empty room? And we
Yes,
could
definitely,
Yeah.
distance,
definitely.
come together for like a review session, maybe once a week.
Absolutely.
Yeah, definitely.
Okay, all right, I don't know if that's allowed or not. Let me double check with the head of my division and see if something like that can happen, and I'll report back to you on Tuesday, okay? Can I try something? Can I try to assign each of you to a breakout room, and that way, if you have a question, I can work with you one-on-one? And that way you can unmute yourself because you'll be in a room all by yourself and you won't interfere with anybody else. And at the end of class, we'll come back together.
Yeah, no problem.
Sounds
Okay, let's see if this works or not. So you've been invited to join a breakout room. So you're going to go to your room.
Okay,
Hi, Desiree.
I was just getting out of this session because I was watching the video. I just started on my math lab. I was watching the video and I was going to ask you if I could just leave.
Okay, and what I've been doing is I'm going into everybody's room and meeting with them. So